So hi, I'm Todd. I'm from LinkedIn. I'm on the SRE team there. And I'm going to leave this slide up for just a minute while I talk about why that's sitting there. This links directly to the slide deck on LinkedIn so that you can follow along and you don't have to take a picture of every single slide because they're all there. So the dog is there because my youngest daughter has a collection of stuffed dogs that she carries around, and she left one in my office before I left, and it was sitting there on my desk, so I figured I was supposed to take it with me. I was wrong. The dog is a stowaway, but I've been sending her pictures, so if you do take some pictures and tag me on Twitter on @Bonkoif there, I will send them to her later and show her how much fun her dog Jana Rita is having on this trip. Anyways, so what am I going to talk about today? I'm going to talk about why everyone's monitoring is horrible, mine included, and I guarantee most of yours as well. There's probably a few pockets of people who feel like they're doing it right. You're probably wrong. That's okay. I'm going to go over some anti-patterns in monitoring that we see all the time. These are actually 3 examples that I have personally lived or created. Talk about setting goals for monitoring, what exactly is monitoring, how you design your systems for success, and then I'll wrap up with a little summary. Before that, who am I and why am I here? So as I said, I'm with LinkedIn Site Reliability Engineering, and I'll talk just a little bit about what SRE is for us in a moment. I've been with the company for slightly over 6 years now, actually 6 years last week. And for most of that time, the first 4.5 years, I was with the Apache Kafka team, but right now I'm with a team called Capacity Engineering. This is a central team that does capacity measurement and management for the entire company, or at least we're going to in the next couple quarters as we get everyone onboarded. Before that, I was doing Kafka, 4.5 years, actually co-authored with my dear friend Gwen Shapira, the definitive guide for Kafka for O'Reilly. And for anyone who's wondering, yes, we are going to start on a 2nd edition shortly. That hopefully will be not too long out. And I'm also a registered locksmith, and you can find me later if you want to hear that story and how that happened. So SRE has a lot of different definitions. If you ask 6 different SREs what it means, you'll get at least 7 different answers because we all need to be redundant. But we all kind of speak the same language. We talk about reliability, we talk about DevOps, we talk about availability, being on call. Thankfully, I don't talk about being on call anymore. At the end of the day, it's all about site up. It's about keeping whatever you're doing up and running all the time and serving your customers properly. And that's generally what we're doing at LinkedIn. Our SRE teams, the central ones, are responsible for developing and maintaining the tool sets around monitoring, deployment, just about everything else that runs the internals of the system. And then our embedded teams, which the Kafka SRE team was an embedded team, they're responsible for specific applications. So we worked on Apache Kafka only and made sure that stayed up and running all the time, defining the bounds around how it's supposed to run. So since I'm going to talk about reliability, I'll probably use the term SRE in a couple places. If you want to talk in more detail about what SRE at LinkedIn is, you can find me afterwards. I'll be around office hours or wherever else. So let's talk about those anti-patterns first. We've all seen a lot of them. The first one I'm going to start with is our Network Operations Center. We no longer have a NOC. We now have a SOC, Site Operations Center. We changed the name to get away from all the pain of the past, because even when I had started, the NOC was doing central monitoring and alerting for the site. They would get all the high-level alerts for the site, and then they would do something about them. So first off, they're gatekeeping all the alerts. So they're saying which ones are important and which ones aren't, and you have to prove it to them. And they have no deep knowledge of any of these systems. In addition, they were essentially telephone operators. What their job was to get the alert and then go through the run book for the alert to try and fix it. I guarantee 90% of the run books they had all said the exact same thing, which was call the SRE. That doesn't really give them any power whatsoever to do anything. So this is not good. We don't want centralized monitoring alerting. We want to have everyone get their own alerts, have everyone own their own monitoring. So the next one is Kafka under replicated partitions. So this is a metric from Apache Kafka. And I am unfortunately responsible for creating this particular anti-pattern. and telling everyone else in the industry it was a good idea. So I'm spending a lot of time backpedaling that right now. This metric has no real clear meaning. So this graph that's up right now is actually one of the brokers in the cluster is down. This graph is one of the brokers is having a problem with data being produced to it. And I have no idea what this graph means. But these are all three graphs from our live monitoring system at various points. So sometimes it's a problem, sometimes it's not a problem. All it says is that all of the partitions in the cluster are not fully replicated. Does your customer actually care if they're not replicated? You might care in the long term that they're not durable, but that's probably an internal concern. The customers can still do everything they're doing. And the great thing is because this isn't always a problem, half the time it just gets ignored, especially when you're starting to get overloaded with alerts. Now, there's a great story behind these particular slides, which I've used in another deck, because I've always, in the past, thrown Gwen under the bus when I talk about this. And for anyone who's not familiar with that idiom, thrown under the bus, it means I'm basically taking her and making fun of her and putting her under the bus for the bus to drive over her and make a mess. She disagreed with me for a long time about the usefulness of under-replicated partitions after I changed my position. And I found out last year when I was giving a talk about Kafka monitoring that she finally agrees with me now that she's running Kafka at a large scale for lots of customers. She realizes how bad it is. So I can't make fun of her anymore. She's come around to my way of thinking on this. The last anti-pattern I'm going to talk about is CPU load. Everyone loves to alert on CPU load or CPU utilization or anything like that. First off, probably half the people in the industry have no idea what CPU load actually is or how it's calculated. It's a relative measure of how busy your processors are in the system. And the great thing is that there's no good or bad. Is 24 bad? Can't really say. If you have 32 processors, then 24 is not that bad. If you have 16 processors, then yeah, 24 is kind of bad. But nobody actually cares. If you have an email server that's delivering email and the CPU utilization's at 99%, what do? Go get a cup of coffee because it's delivering email and that's what it's supposed to be doing. CPUs are actually supposed to be busy all the time. If they're not busy, you're wasting resources. So 100% CPU is not inherently a bad thing. We also have no idea what's causing high CPU utilization. It could be your application, it could be a monitoring application, it could be the kernel itself causing a problem. There's any number of things. It doesn't actually give us a clear signal for what's wrong. Could be capacity. Maybe, maybe not. Everyone likes to think that CPU utilization is this golden signal for when you need to increase capacity of a service. And I can tell you, having worked in capacity engineering for a year and a half now, that could not be more wrong. And I am constantly fighting right now on a daily basis people who have that simplistic view of what capacity is and trying to educate them as to why that doesn't really work and you need to measure other things. So if all these things are bad, then what's actually good? What do we need to do? And the answer to this is that we need to set goals about what we want our system to be doing. We need to define what is good and what is bad. And the way we define what's good and what's bad for most of our applications is with service level something. So I've got 4 terms here. I'm going to define 3 of them, and one of them is a copy. So SLI is service level indicator. This is typically a metric. It's something that you measure that will indicate whether your service is in a good or a bad state. A service level objective is a combination of a service level indicator and some sort of threshold that says when it is good and when it is bad. It also usually includes a time period for measuring it over, possibly how it's being measured as well. So it will define how do you determine when something is good and when something is bad. SLT is a service level target, and it's basically exactly the same as service level objective, except ITIL decided to change the name some years back for reasons that nobody can fathom. You'll hear it every once in a while, but most people still use SLO because nobody likes ITIL anyways. ITIL is IT something. Yeah, thank you, infrastructure library. As I said, I don't like it, I don't use it. And SLA is a term you will often hear people use when they mean SLO. And SLA is a combination of a bunch of SLOs and a penalty for what happens when you don't hit those SLOs, and often definitions about how you provide service to your customers, who they call, when they can call, what the response times are. Most of us, when we're talking about internal applications, do not have SLAs. You are not going to walk over to the database team and say, hey, you didn't hit your latency targets, you owe me a case of beer. You might do that, but most of the beer flows freely in my company, so it's not really something we can use to barter with. So we probably don't want the term SLA. I correct people a lot on this. We're going to talk about SLOs today. So how do we set our SLOs? There's two ways that we often talk about this. We talk about achievable SLOs and aspirational SLOs. Achievable SLOs are targets you're already hitting. They're looking at how your application's been performing and saying, hey, I can do 100 milliseconds all the time. 100 milliseconds is my SLO. That's not a bad thing. Sometimes all you need is an achievable SLO. You want to define something that you can do and continue doing that. Sometimes if you have a business need, you need to define an aspirational SLO. So this is what I have to be doing because there's a reason for it. It's something that the business needs. So you may say, well, I'm doing 100 milliseconds of latency, but I actually need to be doing 50 milliseconds of latency. 50 milliseconds is my SLO, and I need to work to get there. It's okay to be failing. Failing is fine as long as you know why you're failing and you're working to get better at it, and eventually you won't be failing. So we need to set our SLOs in an intelligent manner, and I like using the SMART framework for this. So SMART is often used for personal goals, quarterly objectives, and things like this. You want to be specific, so you want to have your SLI, your time period, your threshold, all of these things well defined. It has to be measurable. Developer happiness as an SLO is not a great SLO because it's really hard to measure whether or not someone is happy. You want to look for things that kind of describe happiness in a data-driven manner. So things that when you know all of these numbers are in the right place, then your developers are happy. Developer happiness is a term we use internally to talk about how well our tools and our deployment pipeline and everything else is working. Because if all of that is working, then the developers are happy and we can sleep a little better at night. Agreed. This is a little bit controversial. You do actually need some agreement on internal SLOs, even though they're not SLAs. And that's because your internal services are providing tools and operations for other internal services. And there are requirements. There are things that need to happen. This is where you get your aspirational SLOs from, what the business needs are. They need to be realistic. If you are operating across the entire United States, and you set a latency target of 2 milliseconds for communications time latency, that's not realistic because the speed of light does not go that fast. So you need to actually set things that you can hit at some point in time. And keep in mind that the tighter your targets are, the more work you have to do to hit them, the more expensive they are going to be for your company. So make sure that you actually do want to spend that money. You're going to hear frequently, every single 9 in availability will cost you an exponential amount more money to get. It is very true. You need to make the decision as to whether or not your cat pictures that you're loading for people actually need to be 5 nines available. Do people care that much? And last, they have to be time limited and they have to be testable. So you define your SLO over a period of time. You'll say, I'll measure this SLO over a week and take the average. Or I'll measure this SLO over a week and I can only have 5 misses that are 5-minute segments of it, somewhere along those lines so that you have a very clear bound over what you're doing. Some common SLOs that you'll see, availability is one. I actually don't like the term availability too much because we've overloaded it now. Availability is usually used to refer to whether or not your service is able to answer requests. But really, in the long run, your availability should be a measure of how well you're hitting your SLOs. So you want to be able to say, am I answering requests? Are they correct? Are they being served in the proper amount of time? So we need a different term for availability in these two cases. I haven't quite settled on one, but I like the overall SLO measurement as a measurement of reliability instead. Latency is a popular one, especially for online services. How quickly are you serving requests? And correctness is a good one as well. Are the answers you're giving back actually the answers they're supposed to be. There's lots of other things that you can measure as SLOs. There are definitely things around security. Etsy, I think, were the ones who did a great thing around time to sleep. Time to sleep is a great SLO for developer or operator happiness of a system when you start measuring those things as well. Okay, so we've got our goals. How do we actually do this thing called monitoring, and what is it? So this is a fundamentals talk. I'm not going to talk about any specific tools in here. Here's a nice textbook definition of monitor. Observe and check the progress or quality of something over a period of time and keep under systematic review. This is the essence of monitoring. You're just watching what you're doing all the time and making sure it's correct. So what the hell is observability? Now, if I could assure that everyone in here was in Philip's talk earlier, I could probably skip a couple slides, but you know what happens when we assume things? We usually break them worse than they already are. So I will spend one slide on observability because this is not actually an observability talk, and then I will move on. A lot of people will tell you it's magic. You bring observability in, everything's going to be great. Just buy some observability, it'll be fine. Pretty much everyone who uses this term heavily is trying to sell you something. That is not a bad thing. There are some very good tools out there around the realm of observability, but this is a term from control theory, which Philip described very well. It basically says observability is the quality of being able to monitor the internal state of your system, whatever that system is. So how well you can monitor the internal state of a system. And I use that phraseology very carefully there. Monitor. So it's a measure of your system. Here's the thing. It's a noun. It's not a verb. You can't do observability. Just try it out. I'm going to do some observability today. It does not work. What you do is you do monitoring. So you have monitoring, and if you do your monitoring well, then you have good observability. Here's the other thing. You don't need perfect observability all the time. You do not need 100% view into everything about your system all the time. Do you really care what the size of a particular array is in your application? Maybe not. Maybe you do. It might be important at some point in time. Just like reliability, just like availability and all these other things, you need to define how good does it need to be, get to that point, and then stop. Don't spend more time on it. All right, enough with observability. So what are we trying to get out of our monitoring? And Philip stole my slide, kind of, and I'm really upset about it. So I'm going to call this the Rumsfeld Quadrant. For those who don't know, Donald Rumsfeld was Secretary of State in the, or Secretary of Defense, I'm sorry, in the United States a couple times, but the period I'm interested in is the early 2000s. In 2002, he was doing a press conference on weapons of mass destruction in Iraq, and he got ridiculed over this because he talked about how there were known knowns, and there were known unknowns, and there were unknown unknowns. He did get ridiculed a little bit because of the language he was using, but he's very correct about how he was describing things. So, along one side, we have the detection of a problem, known and unknown, and along the top, we have the response to the problem, known and unknown. So whether or not you can solve the problem or can't. So this is a little bit different than the graph that Philip used, so I can be a little less upset. So if you can detect the problem and you know how to respond to it, you have good monitoring in place. That's great. Automate that problem, because you know what the response is. Write automation. You don't have to worry about it anymore. You don't actually need an alert on that anymore. You just need monitoring, and you need your response, but you don't need to be alerted about it. Good. If you know how to detect the problem, and you don't know how to fix the problem, then you have an active incident going on. You're working on this right now. As soon as you figure out how to fix the problem, then you have a known known again. Automate the response to that. Have your monitoring in place. No more alerts. Great, we've moved it up to known known. If you don't know how to detect a problem, but you know how to fix it, then you have a monitoring gap. So you have something missing in your monitoring. Fix your monitoring, that becomes a known known, automate it, you're done, no more alerts. So the unknown unknowns, what are these? This is when people are on Twitter ridiculing your company, or on your internal Slack ridiculing your team, depending on what the service is. These are the ones that we need to know about. These are the ones that we actually need to monitor and alert on. But if we can't detect them, then how do we know that we have an unknown problem? The answer is SLOs. If you monitor your application from the point of view of your customers, then you will know when you have a problem, even if you don't know what the specific problem is. How do we get to this point? How do we build our monitoring stack? These are all things you're going to be familiar with. We're all in this space already. We've heard a lot of these things. So we have metrics, which are single numbers, and we have events, which are structured data. These are two basic types of data that you have to work with in the monitoring space. So metrics are things like counters or gauges, rates, histograms, quantiles, summaries. It's a string of single numbers. Very useful for alerting because you can set a nice threshold for them and then move on, and you either have an alert or you don't have an alert. Structured data are things, log messages. Hopefully they are structured log messages. If they are not structured log messages, you are a bad person and you should feel bad about yourself. Tracing is in this space as well, distributed or otherwise. If you think you haven't used tracing before, you're probably wrong because I think most of us have put print statements into our code that say, why the hell am I here? Print 1, print 2, print 3. Oh shit, this should never happen. That's rudimentary tracing. We rip them all out afterwards. Tracing means you leave them in prod so that you can get to them later. So that's a collection of events. Now, you can't turn metrics into events. You can't add more data to the metric to get to an event. You can turn events into metrics, however. You can count the number of events of a specific type and create a metric based on that. Does this mean that events are inherently better than metrics? No. They give you different things. And collecting an event is much more expensive than collecting a metric is. You can put hundreds upon hundreds of metrics in your application before you even get to the cost of adding one event. I will caution you, however, you can tank your performance with metrics. If you have hundreds of thousands of metrics in your application, you will see a performance hit from that. I know because Kafka does it. It's bad. So where can you get this data from? Again, there's two types of places you can get your data from, subjective and objective. Subjective is an internal view of something, objective is an outside view of something. So subjective metrics are things where you have your application monitoring itself and emitting its own metrics about what it's doing. Most service latency metrics fall into this bucket. The good ones don't, but most of the ones we have actually do. It gives you rich data on the internal state of your system. This is great. This gives you higher observability as to what your system is doing on the inside. It gives you lots and lots of data, but it's often questionable data because it doesn't tell you what your customers are seeing. It just tells you what the application itself is seeing. And you can cause a lot of problems here, both with performance and with tricking yourself about what your system's actually doing. For example, that latency metric where your application says, hey, the latency is 5 milliseconds to process this request, but there's 50 milliseconds of network time getting to you, and oh, the OS is adding another 100 milliseconds of wait time in the TCP IP stack somewhere that you're not aware of at all, and it's not showing up in your application metrics. So objective metrics are a customer view of your system. This is looking at your service from the outside. Synthetic monitoring falls into this space. Anything where you're sending requests into your system and measuring it from outside. Down for everyone or just me on the internet is a great example of this. You put in a website and it tells you whether or not it can get to the website so that you know, is it a problem with the website or is it a problem with your path to the website? Could also be a problem with everyone's path to the website, but again, do you really care whether or not it's their network provider that's having the problem or the site itself? All you know is that Google's down and you can't find out anything you need to know about anything. You need these for SLO monitoring. The only way to monitor your customer SLOs is to monitor them from your customer's point of view. And these are harder to do. You have to add extra systems to do this, but it's usually worth it because they're the authority on whether or not your service is actually broken. Your customers don't care if your service is up and running if they can't get to it. It does not matter to them. Again, neither of these is inherently bad. Neither of them is inherently good. They tell you different things about your system. You need both of them. Anyone who tells you that you only need distributed tracing and you don't need metrics and metrics are horrible is trying to sell you distributed tracing. Anyone who tells you that metrics are the only thing you need and you don't really need these fancy events is trying to sell you monitoring. Everyone's trying to sell you something all the time, except for me. The only thing I sell you is LinkedIn Premium Services, and you should all go sign up for it because it's great for your career, but it has nothing to do with monitoring and observability. So now that we know what we want to measure and how to measure it, we have to design our systems. This is where you have to think early and often about what you're doing. So you always want to build your systems to fail, because they are going to fail all the time. We have an on-call room here. That's why, because your systems are failing all the time. You need good instrumentation on every aspect of your system. This doesn't mean millions and millions of metrics, but it does mean trying to identify the right metrics to tell you about the internal state. You need to have good availability. You want to tolerate single component failures in your system at all time. This might be n+1. You might be able to get away with just one extra. It might mean 2n+1, depending on what you're doing. You need enough services so that you don't need to be alerted for a single node going down in the middle of the night. You should be able to deal with that the next day. And then on the capacity front, you want to limit the resource creation and utilization in your system so that a single bad actor can't run you out of capacity for your service. Think about DDoS protection, quotas on data infrastructure systems. Everything like this will help get you to that space. And then you want to use your SLOs for monitoring, because it's the only thing that actually matters. If you think back to that Rumsfeld Quadrant, the only things we actually need to alert on are the unknown unknowns, because everything else can be automated away after you do a little work. So you want to always measure your SLIs, whatever you've defined them to be. You want to have objective monitoring for those. It's the best thing you can do for your SLO-based monitoring. For observability-based things, for knowing the internal state of your system and debugging your problems, you need more subjective monitoring techniques. But for SLOs, the objective method is best. You don't want to beat your SLOs, at least not by much. So if you set your SLO at 99% availability, and you're always 99.9% availability, then guess what happens? Your customers assume that the SLO is 99.9% availability, and when you are 99.1% available, they will be complaining, even though that's not what you promised. So you want to beat your SLO by just a little bit, but not much, because you don't want to set a new assumed SLO in place. And you only want to alert on the SLOs. And I love making definitive statements like that, because it always generates a great discussion later with people who disagree with me, and I love it when people disagree with me. So SLOs find your unknown unknowns. And anything that's known unknown or unknown known, which is an active incident or a monitoring gap, has to be temporary. You have to solve those problems. If you're not solving those problems, then you're probably just sitting and playing Minecraft to tweak your Docker configuration, and that's wasting everyone's time. Known knowns should always be automated. If you know how to solve the problem, then make the computer do it for you. That's our job, is to make the computers do things for us. Make it do it. Automate yourself out of a job. You will still have a job. Developers are horrible. They're changing things all the time. They're going to cause more problems for you. Don't worry about it. And anything else that doesn't fall into the category of an SLO, you can alert on it if you have 100% signal. If you absolutely know that it describes a problem, yes, you can create an alert on it. But I will ask you that if you have that going on, then why didn't you automate the response to it? And if you have something that is not an SLO that indicates a problem every single time, why is it waking you up if it doesn't actually impact the SLO? If the service can continue running and a server is down, do you need to be woken up in the middle of the night for that? Or can it be solved the next day? That's what you want to go for. Capacity is the one thing that people will start arguing with me on this about the first time, every single time, because you have to alert on capacity. You have to know when you're running out of resources for your system. You really don't. First off, use quotas. So assure that a single user can only use the amount of resources that you've given to them at any point in time. And use quotas for online services and for data infrastructure. They're useful in lots and lots of places. Report and review on capacity regularly. So you want to be able to respond to changes in the trend, changes in organic growth at any given point in time. But you need to report and review, because in the middle of the night, if you get paged for a capacity problem, I don't know about you, but I can't make a rack of servers magically appear in the middle of the night. It just doesn't happen. Now, AWS and Google Cloud and Azure all changed that a little bit. Yes, we can magically make new VMs appear in the middle of the night. But if that's the case, why didn't you automate that? And always act promptly on your capacity concerns. So if you have that extra rack of servers, get them installed. They're not doing you any good sitting there idle, unless you're really just trying to save on electricity and cooling costs, and that's probably not what you want to do. Don't put this off, because it will bite you eventually if you put off this work. So review it constantly and get it updated constantly. That's really all you can do to solve your capacity problems. With that, I am pretty much at the end of what I was going to talk to you about here, which is great, because I still have time left for questions. So what are you going to do next? What are the things that you need to walk out of here and do? What are the things that I need to walk out of here and do? Because I'm actually fighting these battles internally. I love talking about this. It doesn't mean I'm actually doing it yet. So you need to define your SLOs. You need to get your customers, whether they're internal customers or external customers, talking and agreeing on what they expect out of your service. And add objective monitoring for all of these so that you can actually see what's going on. Clean up all your alerts. Make a list of all your alerts, figure out which ones seem to be good and which ones are actually giving you noise a lot of the time. Add alerts for the SLOs, implement quotas, basically clean all this stuff up and get rid of the things that are causing you pain at any given point in time. A couple of years ago, Kafka was in a place where we were just having all kinds of capacity problems and other things at LinkedIn. Turned out that the biggest problem was that 90% of our alerts were not actionable. And that was just driving everyone crazy, especially since I think we had a 3-person on-call rotation at the time. So everyone was in a bad state all the time. I spent many nights yelling at my manager, which is why I'm no longer on the Kafka team. And add instrumentation for everything. So if you haven't switched to structured logging, switch to structured logging. Add distributed tracing, especially if you have a distributed system. It's the only way you're going to monitor it, or add internal tracing. And don't hold all of this extra information any longer than you need to. One of the wonderful things about our internal monitoring system at LinkedIn is that it is completely self-service. You can annotate a new metric, and it automatically gets picked up and carried into the system, and you get lots of graphs. It also has essentially infinite retention for everything, with a little bit of degradation of the quality over time. But I'll tell you right now that in the Kafka space, there's probably 20 metrics that we care about retaining for more than 2 weeks. The rest of them are completely useless after we've finished debugging a problem. So make sure you're only retaining things for the appropriate amount of time. And if you want some more information about some of the things I've talked about, you can either find me afterwards, and I'm happy to talk about all these things. We've done a talk and a blog post on what we call Code Yellow, which is a process that we use internally for dealing with teams that are overburdened, that have too much toil or have other problems going on. It's actually a pretty useful framework, and anyone can implement it. It's nothing specific to LinkedIn. Done several talks about SRE, and my colleague Ben Pergeson, along with David Henke, our former head of SRE, wrote a blog series called Every Day is Monday in Operations, which is a great read. And it starts at everydayismondayinoperations.com, so it's nice and easy to remember. And then if you want a deeper dive on monitoring in Kafka and all the things that I've told people are wrong, then there is a talk that I did last year in London on monitoring for Kafka. And then you can find me, the best place is actually on LinkedIn. It may sound like I'm selling something to you, but it is actually the best way to reach me at any point in time, because I'm always looking at it. Or Bonkoif on Twitter. I'm on there infrequently. And with that, I would love to take any questions that people have, or maybe arguments that you want to start. Okay, so the question was about how do you get started with SRE when your leadership won't fund it and you don't have dedicated headcount for it? The answer is that SRE isn't necessarily a job, it's more of a culture. So SRE is really kind of hovers around the culture of being blameless and having open and honest communication to start with. As soon as you do that, all of the practices of SRE kind of fall into place. So you don't really need specific headcount to start SRE. What you need to do is you need to start promoting the cultural change that you want to see that will then just make SRE naturally appear in an organization. And that's being able to talk about problems openly. And this is one of the things that I actually cover in the Code Yellow talk, and why that works so well is when you start talking about your problems and you know you're not going to get blamed for them happening or what the fallout was, then people are far more likely to solve those problems proactively, solve them easily, you get more information flowing. So I always point people to the culture first and then worry about the head count and everything else later. It's the best answer I have for you, Florian.
That's a good answer.
All right, good. Well, then thank you very much, and I'll be around if you have any questions.